Well, hey everyone. Well, thanks for hosting us, Hashicorp. It's been great to be here. And from looking at what presentations we had already and I visited, we have a couple of big shoes to fill. So just a quick introduction. I'm Tobias Haag. I've been with Yammer for the last 4 years, and for the last 2 years been working pretty heavily on data center automation, and now our current ongoing work into Yammer's transition between our current on-prem data center and Microsoft Azure. With me today, I got Kyle Gordon, who's going to introduce himself and get started.
Yeah, my name is Kyle Gordon. I've been with Yammer for about 3 years now. And as with Toby here, we've been working for the past year, 2 years, working on building out new data centers for Yammer and within Microsoft. And today, we are here to tell you about as we migrated into Azure, how we've decided to start using Vault for all of our secret stores. And, in our opinion, you should use it too. So first, a little background. Yammer was founded in 2008 as a TechCrunch startup, and then 4 years later, we were acquired by Microsoft. So Yammer is a social enterprise networking site. So it's kind of like using for businesses to talk back and forth with each other, and to kind of like water cooler talk online. And our typical kind of like workloads are microservices. So we have something along the lines of about 100 microservices, all tied together with a single Rails monolith. Most of our traffic is actually 90% real-time traffic, web queries. We have very few batch background workloads, so a lot of our stuff is deployed and we want to keep it running. And many of our services have dependencies within other services. So as there was a microservice talk a few days ago, or yesterday, that basically detailed how microservices that then talk to other microservices that then talk to other microservices. So there's a lot of like layering there. And there's also a large variety of data stores. We have like Postgres, React, HBase, and all the other things that we have to like keep secret and keep safe. Lots of secrets there. So we do work for Microsoft, but you also see that our stack is not Windows. We are a Linux shop. I know, big surprise. We run primarily on Core OS. For those that aren't aware of what Core OS is, it is a flavor of Linux that has the advantage of being a read-only environment. Its whole purpose is to kind of run your entire systems within containers. And so to run our containers, we use Docker for this. To orchestrate all of our containers, we also use Mesos and Marathon. We made this decision before Nomad had become GA, so we will obviously, over time, investigate using sometimes Nomad going forward. But right now, Mesos and Marathon fits really well with our stack. We're also on Azure right now, so that is where the cloud environment of choice, because we work for Microsoft, so it's obviously by our choice. So, we are able to run Linux on there. And being a cloud environment, there are a lot of requirements for our secret store that played into the fact that we're running on Azure and using Linux. We do run multi-region, multi-geos. We use Team City to kind of tie together all of our deployments for like continuous integration, continuous deployment. And it does a lot of stuff with Vault to help with the security aspects, and also with deploying through Mesos and Marathon. And is responsible for building like Docker images. It does a lot of the stuff for us. And for authentication, we use OpenLDAP. And the reason that's important because we use Vault very tightly coupled with LDAP. So the big thing for us is when we're looking to go to Azure is we have a lot of internal security requirements. Being a part of Microsoft and part of the O365 suite, which is Microsoft Office, Microsoft Word, all of the online Windows tools, there's a lot of security compliances. If you see here, we have 5 bullet point lists, but if we were to abstract each of these, this would be about 200, 300 lines long of individual documents that we have to comply with. But for the most part, the bullet points are intra-data center transport encryption, so everything has to be encrypted, all web traffic, even between our own internal microservices. Just-in-time developer access to assets. So developers do not have access to production or the ability to deploy stuff except through a mechanism to give temporary access. And we have to have strong encryption of secrets, very strong encryption of secrets. So stuff like plain text obviously won't work. And all of our disks have to be encrypted by default. So it's very important that everything is very encrypted, as I said, on wire, all our passwords, certs, etc. Everything has to have an audit trail. So every time a secret changes, we have to know who changed it and when they changed it, and if possible, why they changed it. And so we needed something, our security mechanism, to have that. And the compartmentalization of resources, the very long word of resources. So one thing that we really liked, especially about Vault, is that you could lock things down. So we wanted to make sure that if we did have a breach, that we could just totally shut off access to our secrets so that we could get rid of the issue. And we also wanted to make sure that one service did not have access to another service's secrets. That way, if one service gets compromised, the rest of the world does not get compromised as well. However, we also, of course, have two customers. We have our customers that pay us money through the O365 requirements, but also as DevOps engineers. Developers are also our customers. So any environment we created, we wanted to make sure it worked well with the developers. So local testing compatible was a requirement for us. We needed the ability to deploy changes rapidly. We deploy over 100 times a day through all our microservices. And if you also include Mesos and Marathon's automatic redeploy when hosts go away, the churn of containers is also much higher than that. We want to be able to rotate all of our secrets without developer interaction. It is our opinion that developers should not really care about what the secrets are or whether or not a secret needs to be rotated. They just need to know that, I need access to a Postgres database. This is how I get access to it. So we wanted something that allows us to rotate the secrets without them even having to worry about it. We also need to handle all types of secrets. So certificates, key value stores, database connectors, binaries, Azure resources, because we use a lot of stuff from Azure. And some of the stuff we've done in the past has been a bit of a problem with that. So, for example, binaries being like Java key stores, we need to be able to have all of these secrets, be able to kind of a generic use of them. And Azure resources, as I said, we use a lot of Azure stuff. So the ability to get kind of like just-in-time access to Azure resources also would be a huge plus. So how did we do this before? As you know, Vault has only been out for a little over a year now. So we had other options. So as a startup, our first choice was to use a private GitHub Enterprise repo and store our secrets in plain text. This was obviously a great idea. Don't do this. Don't. Plain text is bad. If the disk gets taken, you're out of luck. People can peer over your shoulder. If people download a Git repo to their local Mac or Windows machine or Linux, whatever you're running, iPhone, who cares? It's there in plain text, and that's obviously bad. The repository might become public. Obviously, not a really good thing. You have to keep complete access of your firewall rules to make sure it never leaks to an open subnet. You have to make sure that all of your users have only the exact access they need to certain repositories. And it's just kind of a big mess, especially when you get to like us, where we have hundreds of microservices, which means you have hundreds of repos. So making sure the access gets scoped down can be a bit of a pain. And then we went from that, we decided to start using, for some of our secrets, encrypted GPG key rings. So this allows us to get the encryption. It also means we can store this in a GitHub repo. Mostly fine. I mean, sure, it's crackable, but at least it's better than plain text. But there's obviously problems, is that we still, central storage isn't there by default, so we use GitHub Enterprise for this to store these GPG secrets. But every time we had to re-encrypt them to add a new user or to rotate a secret, you upload a full blob, so that totally gets rid of the history. And if you use something like Git Secret, which does a lot of the stuff for you, your repo size starts to grow rather quickly if you have lots of secrets. So managing multiple of these would also be a bit of a pain. And it's just a little bit, not in the deploy story. You also have to have the keys on all the hosts. Rotating those is a pain. So that also is not a really good solution for us. So we also have something else we built in-house. We called it Secrety. The problem with building in-house, of course, is that there's no vetting for it. It's all internal. We're not security experts. So what we did, all of our choices, probably wrong. I mean, we did once put everything in plain text, so probably made a couple of mistakes there. And constant maintenance required. We want to work on other stuff. Our team isn't the largest team in the world, and there's other teams that are concentrated on this, so we need something else. And then not on this slide, we also looked into Azure Key Vault, which is something similar to Hashicorp Vault. I made a mistake there because it's very easy to make a mistake when you have two technologies named Vault. So Azure Key Vault was pretty awesome, but it didn't have all the features of Hashicorp Vault. So we decided that what we wanted to do is we wanted to take a look at Hashicorp Vault. So there are a lot of reasons why we want to use Vault. Open source with an active community, always a plus. There's, as we mentioned, we're not security experts. There's plenty on the internet. There's also Hashicorp can hire their own security experts, or they can have them as part of their clients. so it's much better for that way. Cross-platform CLI, it's built in Go, so if we want to run it on a Mac or a Windows machine or a Linux machine, we can just cross-compile it, and it works great. The CLI and the API are practically, if not 100% identical, which means that there's no maybe like drift. So what we're using in production, you can also modify in staging or development. Generic secret backends with their name spacing, so it's the pathing. That was a really big boon for us because, as I mentioned earlier, we wanted to make sure that our secrets between services did not cross-talk. So this was really helpful for us. Runs HA, which is very important because we're running in a cloud environment. It runs in Docker, which makes HA even more important because it's running in Docker. Simple user interface service, simple user service management via policies. So it's very simple with the HACLs to just create a policy for yourself and for other users to manage your secrets and access to them. Huge, awesome. That is way better than anything we had before. Supports a lot of backends out of the box, so that's stuff like using LDAP, using the PKI backend, using the general secrets backend, multiple auths as well. So it meant that we could use this for more secret rotation than just what our service deployment is. And Tobias will get into it in a little bit about how we actually leverage that in our day-to-day work. And it's not tied to a platform, so we can use it in AWS, Azure, Google Cloud. Even though I said we're Microsoft and we're using Azure, it's not possibly always going to be the case. So if we have to switch to a different platform, we have the ability to. So that's always awesome. And the secret rotation, as we mentioned, is baked in. We don't have to really do a whole lot of stuff with it. We don't have to manage the rotation of all of the keys. We just have certain keys and tokens. And with the different authentication backends, we can manage it via LDAP or using the client's certs. So we decided Vault's awesome. So let's dive in and let's try it.
Cool. Thank you. So it's pretty clear why we use Vault, I think, at this point. When we started out, it wasn't quite as clear, though. I stumbled upon, I think, the 0.40 release of Vault, started to investigate. We had other contenders. Kyle mentioned GPG keyrings. We looked at Blackbox to just manage them and try to figure out how we can automate this process in a platform that dynamically spawns Docker containers, especially since Docker has been relatively unstable in some recent versions in a sometimes hourly interval. And if you really have to deploy or manage secrets in that fashion and at that time scale, you really want to have something that is solid, that is reliable, that's always available. So we started out using Zookeeper as the backing store, and that was before the time where Vault decided, or Hashicorp decided, to split the HA storage backend, or the HA backend from the storage backend, which is something we always wanted. We were pretty clear-cut, or pretty convinced that we had to have HA very separate from where we stored the data. Zookeeper, yes, we can store data because it's already encrypted by Vault. That's great. However, we wanted to also have encryption at rest if possible. Azure Blob gives you the ability with the click of a button. It looks slightly differently if you have to use your OS disk for this because you take the slowdown of the OS disk and the whole OS with it as well. And also, we run only one big Zookeeper cluster right now per region, and we have multiple regions, obviously. But the Zookeeper is actually heavily used by Mesos and Marathon as well, so they are all shared. At which point we really want to make sure that we don't put as much load on it, or as little load on it as we can. What we ended up doing very, very early on, we were a bit, well, I was a bit hard-headed about this, is to wrap everything into Docker. If it goes onto Azure, it has to be in Docker. We had our data center automation platform that we run as a legacy system right now that wraps everything into LXC containers already. And we went back on this a little to some extent for HA proxy, load balancing, high performance network applications. And I was really sad that happened. So we went and said, okay, let's wrap it everything. And Vault was just a breeze to wrap. We right now have a Docker image of 25 megabytes in size that has Vault in it. And it's blazingly fast. So thank you to Alpine, thank you to Vault for making this a Go application. And when it comes to instrumenting how Vault interacts with a system like Mesos and Marathon that isn't natively tied like Nomad is and doesn't have the ability yet, we had a couple of choices to make of how we handle service authentication and make sure that a service doesn't leak its credential set, for example, to other services, or other services can access the credentials of neighboring services or even databases and similar things. So and I get into this in the next slide, it's a relatively complicated scenario. It reminded me a lot of the Nomad flow, though it has a distinct difference to it. We also went the way similar to Nomad's implementation of the lowest amount of trust we can hand out is what we want to aim for, because we cannot necessarily trust Azure and the hosts necessarily because it's a shared environment. It's not our own data center. We share it with third-party customers. We share it with first parties. So we should always assume that the network and potentially the data center is at all times compromised. So how do you protect yourself against that? One thing that is also mentioned here at the last point is we wanted to ensure that developers, well, obviously not maliciously, that would be really bad, but also not accidentally compromise security. So we actually force entry points onto them that handle a lot of the logic of how the authentication flow that we use works. And it allows us to relinquish permissions and force a user into, or force a Docker container into a Unix user at a later stage, so we don't run anything at root, as root inside a container even. So let's get into that one. So how does it work? Let's see, I always wanted to do this. Ha, cool. So there's two parts to this, and we heavily rely on AppID authentication flow, which is now deprecated. But as I was told, the app role flow should provide similar means, if not even better means of achieving the same thing. So we're probably going to look into implementing this relatively soon. But the way it basically works is that our ops team, and this is just a user-driven approach, when an application is first onboarded, will generate an app ID for a new application. That's pretty straightforward. We then map this application to a set of policies, whatever the application needs. For the most part, this is just generic backends, key value secret stores, but it can be as elaborate as Postgres auto-rotating credentials with fixed TTLs. We really leave it up to the service to decide that, but we're trying to force them into more auto-generated or very dynamic secret stores or secret implementations, secret backends. So once that app ID is there, and Kyle mentioned it, we use TeamCity actually in front of Mesos, but I didn't want to make this even more complicated. So let's just say that someone schedules a service in Marathon. It is very similar to every other containerizer or orchestration framework out there. You specify a couple of instructions that the service should run. In our case, that's what Docker image to run, what environment variables to use. And one of those environment variables is the app ID that has been assigned to it. Once that task and that job is submitted to a suitable host, what will happen is that we start the Docker container and we mount in two files. One is a TLS certificate, and one is a user ID that we source from the core OS machine that is unique across all machines inside our cluster. We obviously mount them read-only because they're shared by obviously every other service that is next to it, and we don't want them accidentally changed because that would wreak havoc on our system. And then the real dance with Vault begins. And obviously we don't have Nomad in place or any other scheduling system that is aware of Vault, so all the communication actually happens on the host level. So we use that certificate here to authenticate via TLS with Vault itself. That returns a token, and that token's policy is only tied to the app ID namespace or the app ID mount point. That's the only thing it can do. It cannot read secrets. It cannot do anything else. And if you listen to a couple other talks yesterday, Vault doesn't give out root policies, and it's really not possible to assign yourself a root token based off of that. Then we do something else. We also add a CIDR block that represents the host IP itself, and then map all of these things together using the user ID and the app ID, and write that back into Vault. So this all happens in the entry point of the Docker service once it starts, and it happens every time. Once we have our app ID mapping fixed and we have a policy attached to that, we obviously need to authenticate again with Vault. And again, this is also happening in the entry point as a root user still. We then do the app ID authentication. That gives us back the token that we actually want to hand out to services, which we then just simply write into the services home space as .vault-token, for example. At this point, we actually drop privileges from root into the application's user space. And with that, the certificates that we mounted in, as well as almost any rights that the user has are just dropped. There's no sudo in those containers. There is pretty much nothing you can do to leak out of this. And once we handed off that secret and dropped our privileges, we actually just defer to whatever the command is that the developers want to run. And at that point, what we usually have is the services will either use the bash or via bash will use the Vault CLI to authenticate with a token they have in their home space and retrieve their secrets as necessary. Or if they're more elaborate secrets, then they will talk to Vault via APIs or similar things. So that's a very complicated flow, but I think I nailed this on. So let's move on. Yes, now we need to use it everywhere. We didn't stop at just using Vault for secrets. Yikes, excuse me. We actually soon realized that there's another set of things, and this came in a later release, that we really, really wanted to have. One of this is how do we control access to containers? Obviously, you don't want to run SSH daemons inside every container. That would not only break Docker's philosophy, but it would make management of this a nightmare. I mean, a single host with SSH is usually bad enough. Multiply this by 12 per machine or more, and nightmare ensues. So we looked heavily into Vault's SSH-mounted backends, and we use both actually the dynamic certificate backend or the implementation, as well as the one-time passwords. And it depends on which team you're in. If you're in an ops team, you get dynamic injected SSH keys, because right now, unfortunately, OTP only works with PAM, and CoreOS doesn't work with PAM. So we're still stuck on this one. But we wrote a couple of tools to actually facilitate making our life with, or facilitate the use of Vault and abstract it away to prevent developers from using Vault CLI directly where not necessary, and also don't have to handle policies and LDAP logins for everyone to Vault directly. So for the SSH one, we wrap it with something called Ninty. It's a Go application as well that uses the SSH helper on the other side of the SSH daemon and the LDAP login to issue one-time passwords on a per-service basis. We have another system that is completely outside that was built in-house that allows us to dynamically map LDAP groups to individual users that scope them to a service. And we just extended on this and provide an SSH session into a limited shell that then forwards you into a container using Docker exec. So people can still debug and get their SSH sessions. They were very adamant about still maintaining access, while at the same time allowing us to limit what they can actually do. Then we wrote another thing. We started looking into our bash usage and realized that it was a lot of boilerplate code. It's the nature of bash. We also run a lot of Rails and Java processes, and the Java processes are relatively simple to handle, while the Rails processes rely a lot on environment variables, for example, and they expected their secrets to be environment variables. And we didn't like that at all to start with, and it becomes even trickier when you have certificates in environment variables or anything with a new line. It really depends on your bash implementation, what shell you use, and ideally you wouldn't use it at all. Environment variables are great for simple values, but they're not great for binary data. So we moved away from bash where we could, and we created something called Temply. Even in our current legacy environment, we heavily rely on Puppet, and we are very used to use ERB templates. And basically, this is an attempt to simplify. Obviously, Puppet has no place in this environment anymore, almost. But now we use Go itself and the Go templating language to inject and collect both secrets and environment variables, merge them together during the execution time of Temply, and provide the developers with a final YAML file, JSON config, whatever they need. And they have the power over providing us with a template, and we just execute this, or they execute this whenever they want, and it does the Vault dance for them. And then finally, our last tool, and is probably one of the strongest ones, is called Lotbrock. It's a client-side load balancing orchestrator, because it turns out in a Mesos marathon environment, everyone has to do load balancing themselves. Everyone keeps reinventing the wheel, so why shouldn't we? We actually had a really good reason, I would say. We had the requirement to do SSL encryption between everything. And once you start mixing Java and Rails and Java key stores and CAs and certificates all together and leave that up to the developers, that gets messy really fast. So we introduced Lotbrock, which instruments and templatizes HA proxy for us, and then we use HA proxy instances everywhere to communicate via SSL tunnels. And because we use SSL certificates, obviously, for one, we have, oops, sorry about that. For one, we have to have certificates there that actually do the SSL dance and can be used to that. We create our own CA for each region, so we at least have a trusted environment that we can use, but we wanted to go a step further. We wanted to make sure that these certificates are rotated as much as possible. So we are on a 6-hour rotation schedule with 24-hour valid certificates, and what better thing to use than the PKI backend from Vault. And that's another great point about Vault, is the CLI and the API are so close together that if you understand the CLI and work with it, implementing the API in Go and working with it as well is trivial. It's fantastic. So how do we handle the management of things? How do we handle permissions? How do we handle policies? Obviously, that is outside of the deployment scenarios. We have to have some management on policies, LDAP user mapping specifically. How do we bootstrap the SSH mount point to prepare them for our dynamic LDAP users and groups? How do we inject secrets, and how do we manage mount points? So for the most part, very lightweight Python. An application is stretching it a little. It's scripts. It's really dumb scripts. They handle synchronizing policies between multiple Vault clusters. And as I mentioned, we run in multiple regions. So our staging environment or pre-production, our production environment already have multiple active regions that we run in. And obviously, the secrets need to be shared. The policies need to be shared. So these Python applications or Python scripts really help doing that. We keep them mostly generic because our services are relatively dumb in their current secret usage. Key values doesn't need a lot. It's a namespace. You're done. We can actually generate them and don't ask developers to provide us their policy with their policy files because they're really, really generic. For LW user mappings as well, we have a very few very static groups and then a lot of very dynamic groups. So for SSH service, user access, we have generic LDAP user mappings that allow us to generate them on the fly based on the service name that they are onboarded with. And for the remaining ones, we just have static LDAP user and LDAP group definitions, very simple. The secret injection, one thing we wanted to do is we wanted to make sure that binary data works all the time over the wire, even if Vault changes. Everything is base 64 encoded for that reason, so when we write them in, again using tooling, we just encode everything, be it already base 64 encoded, we just double encode it. And it also drove a little of the decision to use Template, for example, as a wraparound this, because no one wants to do base 64 decoding on the bash shell, or caught unaware of that, which we had happen as well. And finally, we never want services to share secrets between each other. Every service owns their namespace. We had an incident in the past that led to very insightful, I would say, or just frustrating epiphanies that we realized if you share secrets and you all of a sudden have to restart 200 instead of 20 machines, well, that's fun. And finally, we started to investigate more into dynamic backends because we want our services to be a lot more dynamic and a lot less hands-on from the developer's perspective. So we also build a way to generically configure mounted backends with that. And that brings me to the last slide. One of our developers, last two slides, sorry. One of our developers, Rao Lee, who just joined us in infrastructure, has been working on implementing a couple of backends. That would be the Azure SQL, Azure Event Hub, and Azure Blob Storage backend. And since we really wanted to run with Azure Blob Storage as the backing storage solution, we actually wrote the Azure Storage backend when I think still during the time of 0.4.0, and then had an internal fork and pushed it upstream with 0.6.0, so it becomes available for everyone to use. It's pretty much the S3 backend. The SQL backend itself right now, as well as all the others, are internal only. SQL is so close to Postgres, we could literally just copy and paste most of it and amend very little things between Postgres or actually MS SQL. And it's been working great so far. We have a service running that rotates every weekend on a Sunday, and it just works. The Event Hub, okay, now I need to focus. What was SAS again? Service access signatures, I think that was it. It's basically a token that facilitates expiry of a credential set as well as the permissions that credential set has. And it's a thing that's pretty prevalent in Azure right now across event hubs, blob storage, and various others. We really needed it for blob storage. We would have needed it for event hubs. And we're going to use way, way more of these in the future. We have a couple of work items planned to fix that. To get more backends in, basically. LDAP being one of them, for example. Now, finally, I think that's one of the things that have been pretty much a common theme across third parties here. What do we want from Vault next? For us, version generic secrets, that'd be fantastic. So we can have multiple timestamped, UUID'd, similar versions under the same namespace that we can rotate and flip between. So in a lot of Azure technologies, the storage explicitly, you have key 1 and key 2 that are always valid. And we would like to have the ability to flip and rotate between them so we can invalidate one without invalidating the other. That would be great. We really want to have a change history outside of the audit logs because the audit logs go to security, not necessarily our developers. And it turns out accidents happen. If you accidentally overwrite a secret in Vault, well, that secret is gone. If you make a mistake and it's an invalid secret, well, you have the hardest time figuring out where it went, what it was before, especially in a fire and forget mode of secrets that I think Vault really encourages to use. Finally, rollback of storage. Obviously, the storage itself can be rolled back technically, but a bit more granular control over that would be really nice to have. We would like to have PKI support on a single mount with multiple CAs if at all possible, though I understand why it is split apart. And then full CRL support. Right now, CRLs can be used. However, you have to invalidate outside of Vault, and having this in a fully managed suite would be fantastic for us. And finally, and I think that's a Go problem more than anything, there is no OSGI for probably good reason. Technology similar to in Golang, so a plugin mechanism for backends, so we don't have to keep an internal fork for internal stuff, would be fantastic to have. And I think that's everything we had. And the next slide, well, is a big, thank you. That's all. If you have questions, Q&A is not here, but outside, just find us and we're happy to answer any questions you might have. Thank you.